All right, detectives, grab a coffee, pull up a chair, and let's get straight into it. Welcome to the precinct. I am your lead detective, and today we have a massive, high-stakes case file open on the Cambridge AS and A-Level Mathematics 9709 circuit. In this room, we treat past papers a little differently. We do not just casually read through them. We treat them like intricate crime scenes completely filled with hidden forensic clues. Today, we are hunting down one of the most notoriously evasive targets in the entire syllabus: integration using trigonometric identities. It is a topic that leaves a lot of candidates completely stumped, but the truth is, it's highly predictable once you understand the exact forensic framework the examiners are using to grade you. I've got my two junior agents working this case with me today. You'll meet Agent Alex, who is amazing at gathering massive mountains of physical evidence but struggles to build a coherent case motive. And then there's Agent Sam, who's incredibly fast but jumps to immediate conclusions, totally skipping the vital forensic confirmation steps. Our job is to synthesize their skills and show you exactly how to crack this case wide open.
To understand why we are dedicating our entire war room to this specific topic, you need to look at the motive. We have an incredible piece of intel shared directly by the top brass, the senior Cambridge examiners themselves. They state, on the record, that the difference between a B and an A star in mathematics often comes down to how well you understand integration using trigonometric identities. Listen to me carefully here. This isn't just another standard chapter in your calculus textbook. This single, highly specific topic often acts as the absolute gatekeeper to the top grading bands. Mastering this proves to the examiner, the ultimate judge in our scenario, that you do not just know basic calculus, but that you possess the advanced algebraic agility to meticulously manipulate complex functions before you even attempt to start integrating. You have to secure the perimeter before you bag the evidence.
Here is our exact investigation roadmap for the day. 1. The top grade difference. 2. Core theoretical foundations. 3. The procedural framework. 4. Maximizing method marks. 5. Top examiner warnings. And 6. Our final exam strategy. Let's move.
Section 1. The top grade difference.
Now, let's step into Act 1 and start re-examining the forensic evidence. I've got a complex, high-tariff Cambridge past paper question pinned right to the center of our evidence board. Let's trace the precise assessment objectives, or AOs, demanded by official examiner reports. The assessment frameworks heavily prioritize analytical depth over superficial breadth. What does that actually mean for you in the exam hall? It means standard, broad answers, or simply memorizing a few double-angle formulas like a robot, will not hold up in court. This is exactly where Agent Alex gets trapped. Alex wants to dump a massive, shallow descriptive statement on the page, listing every identity known to man. But top-performing candidates? They act like seasoned detectives. They build deep analytical logic strings. They explicitly show an evaluative argument for why they chose a specific trigonometric identity to break down that integral. Misinterpreting an examiner's command word is literally like a fingerprint match error. It instantly throws out your entire case. You have to read the command words meticulously to know exactly how deep your analysis needs to go.
Section 2. Core theoretical foundations.
The theoretical architecture of a perfect, bulletproof answer rests on a solid foundation of precise definitions and causal relationships. But I need you to pay special attention to cross-topic connections. Our intelligence feeds, the principal examiner reports, explicitly highlight the candidates who reference cross-topic connections achieve significantly higher tier bands. This means you have to link your pure trigonometry to your core calculus. Sometimes it even means recognizing how boundary conditions from an entirely separate physical context apply to your integration limits. You have to demonstrate absolute mastery of fundamental principles that are transferable to totally unfamiliar crime scenes. You can't just know how the weapon works. You need to understand the physics of the trajectory. That interconnected theoretical web is what the examiners are actively hunting for when they scan your paper.
Section 3. The procedural framework.
All right, Act 2, the peer interrogation debate. Right now, I'm watching Alex and Sam at the evidence table trying to stitch together an unassailable model response to present to the judge. They are totally clashing. Alex is frantically trying to overload the text block with long lists of textbook definitions, trying to secure points through sheer volume. Sam, on the other hand, is rolling his eyes, fighting to just skip straight to the final answer to beat the clock. Sam is pacing the room saying, "I know the integral of cosine squared in my head, I'll just write the answer." I have to step in and slam my hand on the table because they are both completely missing the most vital concept in Cambridge grading, the method mark strategy. Please, lock this into your brain right now. Examiners award marks based on your clear procedural reasoning and structured, step-by-step working. If you just give them the final answer, even if it's correct, they throw it out. It's like bringing a suspect to the station without any arrest warrant or chain of custody. You have to shift your focus from merely finding the right number to actively proving your analytical logic string right there on the page.
So I grab a red marker, and I rewrite their response out loud, line by line, creating a perfectly balanced block of text using this 5-step procedural framework, directly from subject specialists. Step 1. Deconstruct the question. What is the exact command word? Step 2. Extract relevant data. Pull out those limits of integration and isolate your constants. Step 3. Select your analytical framework. This is where you explicitly state your chosen trigonometric identity on the paper, proving your motive. Step 4. Execute with clear notation. This is non-negotiable. Do not drop your dx or your integral signs mid-working, or your chain of custody is completely broken. And Step 5. Present with correct terminology. By forcing Alex to organize the raw data and forcing Sam to actually write down the intermediary steps, we successfully build a perfect exam response that literally forces the examiner to award full marks according to their own rubric.
Section 4. Maximizing method marks.
We are moving into Act 3, and right before we lock in our final suspect profile paragraph, we are hitting a roadblock. The evidence links are collapsing under cross-examination. Case file, freeze. Before I step in and give Alex and Sam the ultimate structural framework to anchor their data and help you clear your upcoming Cambridge sessions, make sure your intelligence feed is secure. Take a single second right now to subscribe to Ace the Exams at the handle @AceTheExams and turn on all notifications so you never miss our weekly forensic exam updates. Whether you're cracking cases at IGCSE, O-levels, or AS and A-levels, we've got the notification bell ringing on our police terminal, so let's get back to the case. We need critical data skills. Even in pure math, you have to extract information accurately, interpret relationships, and draw evidence-based conclusions. In the context of trigonometric integration, interpreting relationships might mean recognizing that an integral involving sine squared requires a completely different tactical approach than one involving sine times cosine. Every single substitution you make must be explicitly based on the mathematical evidence presented at the scene.
To fix the agent's collapsing paragraph, I introduce them to the Peel matrix framework. Point, evidence, explanation, link. It's traditionally an essay tool, but it works brilliantly for complex math logic strings. Point, state the identity. Evidence, show the substitution. Explanation, perform the algebraic simplification. Link, execute the integral. Read this direct examiner insight. Top-scoring candidates demonstrate evaluative thinking by questioning assumptions and justifying decisions with evidence. An A-star student actively considers different perspectives. Before you rush in, you evaluate. Does the substitution actually simplify the integral? By clearly showing your Peel logic path on the paper, you are actively justifying your decisions with cold, hard mathematical evidence. That is evaluative thinking at its finest.
Section 5. Top Examiner Warnings. Act 4. The Interactive Viewer Evidence Room. I am officially handing the investigation files over to you for a live forensic check. Let's do a visual clue scan. I'm putting a 60-second digital countdown timer on the screen in my mind, and I want you to imagine a complex source data chart displaying common trigonometric integral pitfalls. Here is the critical question you need to extract the core trend for. Why do students lose easy marks on trigonometric integration? Think about your own past papers. Have you ever successfully navigated the hardest part of an identity substitution, nailed the pure calculus, only to drop 2 incredibly easy marks right at the finish line? Let's reveal exactly what the examiners are seeing year after year in the evidence room.
For Challenge 2, we are going to identify the counterfeit answer. I'm pulling up a flawed, medium-tier sample student response paragraph, and we are going to locate the exact sentence where false logic destroys the mark integrity. Here are the top 3 unforced errors. Number 1. Forgetting proper format. Dropping integration signs or misaligning equal signs is an instant red flag. Number 2. Failing to check presentation. If your sloppy handwriting makes a squared symbol look like a multiple or a minus sign gets lost in the margins, you bleed marks. And number 3, the ultimate counterfeit move. Answers are not specific to context. A student might do flawless math, but if the scenario models a physical volume and they leave a negative answer without explanation, the logic completely shatters.
I am taking my digital marker right now to isolate these discrepancies on the board. Look at the difference between a generic answer and a context-specific answer. The absolute classic rookie mistake is providing a floating, abstract mathematical value when the question gave you a very specific real-world scenario. You must always link every single point, and especially your final evaluated answer, back to the given context. If that integral represents physical displacement, your final answer absolutely must reflect that reality, including units. Never leave the evidence hanging. Tie it directly back to the original crime scene.
Section 6, Final Exam Strategy.
We have reached Act 5, Case Closed and Investigation Recap. Alex and Sam have successfully compiled their final, high-scoring text block, and our case resolution bar is hitting a perfect 100% mark potential. But before we adjourn, I am distilling this entire session into 3 universal rules you can take into any exam hall. Rule 1 is the 3-step question scan, which is all about decoding the exact command words before you pick up your pen. Rule 2 is clock budget allocation, which ties into this memory hack. The syllabus suggests creating a custom mnemonic using the first letters of key terms to lock in the identity frameworks. Under the brutal pressure of a ticking exam clock, having a fast, reliable memory recall trick for your double angle or Pythagorean identities saves you precious minutes, effectively managing your time budget.
And Rule 3 is the final evidence audit. This is your ultimate review checklist summarized right here in our action plan. First, you must practice past paper questions relentlessly. It is the only way to expose yourself to the devious ways Cambridge disguises these trigonometric integrals. Second, execute the 5-step framework we built today every single time you practice. If you skip steps during your homework, you will inevitably skip them under the spotlight of the exam. And third, audit your final evidence by always linking back to the scenario. Apply that method mark strategy rigorously, proving every single jump in your logic step by step.
Case closed, detectives. But the real work starts when you leave this precinct. When you sit down for your actual exam, when that timer starts ticking, and you turn the page to encounter a totally unfamiliar context involving a massive trigonometric integral. How will you actively apply this procedural framework to secure that A-star? Remember, the top-tier marks are never just in the final answer. They are entirely in the forensic evidence of your mathematical thinking. Keep your formatting razor sharp, trust the procedural process, and never let a command word slip by you. If you want to keep training with the best, make sure you hit subscribe on Ace the Exams at the handle @AceTheExams. Click that notification bell for our weekly grade masterclasses, and drop a comment below right now sharing exactly which Cambridge subject and level, whether it's IGCSE, O, AS, or A-level, you are preparing to conquer next. Stay sharp, and I will see you at the next crime scene.